Good evening, students. This is the session 7 from the playlist of alternating current, and today the topic for this session is LCR circuit. So, LCR circuit is basically a circuit which consists of an inductor, capacitor, and a resistor. So, here I have taken one example in which these three components are connected in series as shown in this figure, and this series combination is then connected to an AC source whose oscillating potential difference is given by this formula, that is V is equal to Vm sin omega t, where Vm is the amplitude of the oscillating potential difference, and omega is the angular frequency. Now, today in this session we will try to understand we will try to derive the phase relationship between this oscillating potential difference and this oscillating current which is flowing in this circuit. So here I have already drawn here one phasor diagram, and this will help us to derive the relationship between this oscillating potential difference and the oscillating current. So here you can see in this figure or in this diagram that the current I is the same in all these three components, that is the inductor, capacitor, and the resistor. So because the same current is flowing in all these three components, therefore I will be representing this I on the phasor diagram along the x-axis. Okay, I will be the reference phasor for in this phasor diagram, and let us first of all take the case of this resistor. Now, since the potential difference across the resistor is in phase with the current, so this x-axis will also represent the potential difference across this resistor, and in the case of this capacitor, the potential difference lags this current by pi by 2. So therefore the potential difference across the capacitor will be represented by this negative y-axis, and this in the case of an inductor, the potential difference across an inductor leads the current by pi by 2. So it will be directed along the positive y-axis, and why it is and the reason behind this is that this the direction of rotation of the phasor is taken anti-clockwise. Because the direction of rotation of the phasor is taken anti-clockwise, therefore the potential difference across the capacitor will be along the negative y-axis, because it lags the current by pi by 2, and the potential difference across the inductor will be along the positive y-axis because it leads the current by pi by 2, and this is when the direction of the phasor is taken in the anti-clockwise direction. The direction of the phasor is anti-clockwise, like this. So now, this is the phasor diagram here. This I is the reference phasor, and this VR is the potential difference across this resistor R, and since both I and VR are in phase, therefore both these two that is the current and this potential difference, they will be potential difference across this resistor, they will be along the x-axis, and for the potential difference across this capacitor, it will be along the negative y-axis, and for the potential difference across this inductor, it will be along the positive y-axis. So in this way we have drawn one phasor diagram here, and phasor is basically a rotating quantity here. The phasor is basically a rotating quantity, and the direction of phasor is taken anti-clockwise. So this phasor diagram has been constructed keeping in mind that the direction of rotation of the phasor is anti-clockwise. So let us consider the case 1. In the case 1, VL is greater than VC, so the net potential difference will be along the y-axis will be equal to VL minus VC, and VL minus VC will be acting in the positive y-axis. The net potential difference of this circuit, that is V, it will be given as VL minus VC whole square plus VR whole square. And now if Z is the impedance of this circuit, impedance means impedance is the total resistance which is offered to the flow of the current because of these three elements. So if Z is the impedance of this circuit, then we can write this equation, this one, as V is, can be written as I Z, and this will be equal to under root of VL minus VC whole square plus VR square. Now I will just square this equation on both the sides, so this will be equal to I square Z square, and I will be getting as VL minus VC whole square plus VR square. Now VR square is can be written as I R whole square plus VL. VL can be written as I XL minus I XC whole square. Here XL and XC, XL is the inductive reactance and XC is the capacitive reactance, and inductive reactance, capacitive reactance and this resistance, they are having the same meaning. That is, this capacitive reactance is the basically you can say it is the opposition offered by this capacitor to the flow of the current, and XL is the reactance due to this inductor, and it is also the opposition offered by this inductor to the flow of the current in the circuit. So from here I can write down that Z square will be equal to R square plus, because I can be taken outside because this is common in both, so this will be equal to XL minus XC whole square. Now here XL is equal to L omega and XC is equal to 1 upon C omega, where omega is the angular frequency, C is the capacitance of the capacitor, and L is the self-inductance of this inductor. So if I substitute this value in this equation, so I can also write this Z square as Z square is equal to R square plus this is equal to L omega minus 1 upon C omega whole square. So this is the impedance of the this LCR circuit, that is Z square, that is equal to R square plus in bracket L omega minus 1 upon C omega. Now the current in the circuit I, this can be written as V divided by Z, where Z is the impedance of the circuit and V is the instantaneous voltage. So this can be written as V divided by, now what is the value of Z? So Z can be written as, this is equal to R square plus this can be written as XL minus XC whole square and under root, and this can also be written as V divided by under root R square plus L omega minus 1 upon C omega whole square. So this is the current, this is the value of the instantaneous current which is flowing in this circuit, and so the impedance here is equal to this. This is the formula for the impedance, that is Z square is equal to R square plus in bracket L omega minus 1 upon C omega whole square, and this can also be written as, impedance can also be written as under root of R square plus XL minus XC whole square. Now similarly, now let's come to this voltage. So the resultant voltage of this LCR circuit is equal to under root of VL minus VC whole square plus VR square. And now if the value of VL is greater than VC, so in that case the resultant voltage, the direction of the resultant voltage is given by this arrow here, and so you can here see that this voltage, this resultant voltage is leading the current by some angle. Let us say this is angle theta. So when VL is greater than VC, then the voltage is leading the current, and if VC is greater than VL, then the net voltage along the y-axis will be pointing in the negative y direction, then this will be equal to VC minus VL, and in this case the net voltage will be lagging the current by say some angle, say theta. Okay? And if VL is equal to VC, so in that case the resultant voltage will be in phase with the electric current. Okay, so these are the three important cases in the LCR circuit. That is, when the value of this VL, that is the voltage across the inductor, is more than the this potential difference across this capacitor, then the resultant voltage is leading the current by a certain angle, and if the potential difference across the capacitor is more than the potential difference across the inductor, then in that case this resultant voltage V is lagging the current by a certain angle, and if both are equal, then the resultant voltage will be in phase with this oscillating electric current in the circuit. So thank you very much for joining this session. In the next session we will now be discussing, we will now be taking a few questions pertaining to this the LCR circuit, or it can be I may be taking up some different type of questions, not only from the LCR circuit, but that can be from the combination of circuits like LC circuit, RC circuit or LR circuit. Okay? So till then, have a nice day. Bye.